Hi, today we're going over section 1.2, which is a real number system. So we have numbers classified into different categories. We have natural numbers, which are given by a capital letter N. These are known as our counting numbers. So when you learned how to count, these would be the numbers that we use. So 1, 2, 3, 4, 5, 6, continuing on upwards. We also have what are known as whole numbers. These are the set of natural numbers and 0. So we'll start with 0 instead of 1, and those are known as our whole numbers. We also have integers, which are given by a capital letter I. These are a set of whole numbers and negative counting numbers. So now we're also going into the negative numbers. We also have what are known as rational numbers, which is any number that can be written as a fraction of the form a over b, where a and b are integers and b cannot equal 0. When written in decimal form, it terminates or has a repeating pattern. We also have what are known as irrational numbers. These are any numbers that cannot be written as a fraction. So for example, pi cannot be written as a fraction. Square root of 2 also cannot be written as a fraction. Now, all rational and irrational numbers are part of a set of real numbers given by capital letter R. So for example, classify each number. So what we'll do is I'll write out each type of numbers and then put these into their corresponding classifications. So we have natural numbers. We have whole numbers. We have integers. We have rational numbers. And we have irrational numbers. So I'll go through these one at a time and put them into categories where they belong. Now, numbers can fit into more than one category. So for example, our first one, 12, is a natural number. It is also a whole number, as well as an integer, and it is rational. Next one, square root of 8. If we did that, it would give us a decimal, so it's not a natural, it's not a whole, it's not an integer, and it doesn't meet the pattern for rationals, so it is an irrational. Next, we've got negative 9.12, so same thing, it has decimal places, so it's not natural, whole, or an integer. We can represent it by a fraction though, so it is rational. 24.35 with the 35 repeating. Because that 35 repeats, it will be rational. Negative 13, because a negative it's not natural or whole, but it will be an integer. It is also rational. Cube root of 36 is not natural, whole, or integer because it will give us a decimal. If we put it in, it doesn't have a repeating pattern. So therefore, it is irrational. Negative 50 over 53 has decimal, so right away we know it's not natural, whole, or an integer, so therefore it is negative 50 over 53 for rational. Negative root 90 would be irrational. Square root of 9 over 12, we can take the square root of 9, which would give us 3, over root of 12, we can't take the root of, so therefore it's irrational. Now, if it was square root of 9 over, say, 16, then we could have taken the roots, in which case it would have been rational. Five to the power of 4 gives us a number without decimals, so it is natural, it is whole, it is an integer, and it is rational. Okay, so work for this section can be found on page 17, numbers 3 to 15.